Yeah, probably.
Anyways, everybody got a copy of notes?
See.
This is polynomials. Of course, there's the definition of polynomial. But anyways, before you read that, what's poly mean? Before you read it. Okay, good. You're like the first class that knows that.
Because of polytheism and monotheism.
So you actually went biblical on that. Good. I've been asking kids what polygamy meant.
That's what I was thinking. Dude.
Look at you having a high moral.
Monogamy.
Never heard those words in my life.
Never heard of polygamy, huh?
Nope.
It's
Multiple
a weird
partners.
way people date people.
A polygamous person has multiple partners.
Oh,
Or
yeah.
polyamorous.
There you go.
Ain't nothing wrong with it.
Of
course.
Okay, back to math class. Poly means multiple. Poly means multiple. You guys know polytheism and monotheism. Are you religious? All right, so poly means multiple. When you talk about a polynomial, it means multiple monomials. What's a monomial? One thing. Yes, mono. One thing. Okay? So an example of a monomial, an example of a monomial, I can't talk today, would be something like maybe 4x, or maybe 2x, or maybe 3. Each one of those in their own right is a monomial, because they're one thing. But when you start putting them together, you have a polynomial, because you have multiple things. Okay? So an example of a polynomial, sorry I can't talk today, would be something like 7x cubed minus 4x plus 3. Multiple things. And the funny thing is you can even call a monomial a polynomial. Because you can always add 0 to anything. And then suddenly you have 2 pieces, right? Right? If I do 3 plus 0, there's 2 pieces. Now it's a polynomial. Kind of funny how that works. Turns out even monomials are considered polynomials. Because you can always add what? 0. Just some stupid little thing. There's more stuff that goes here because there's actually some important stuff in that box. So everybody gotten all the pink text written? Parker, you good? So what's in the box is kind of important. Not necessarily the mathematical definition, but the text under it is very important. So there's a mathematical definition, which you don't have to write if you don't want to. You're more than welcome to, but this is important. All right, let me extend it on. Exponents are positive integers. That's important. How many of you have Buckley? You probably know what an integer is now. What's an integer? Please tell me I don't have to start doing the Venn diagrams and the real number system quizzes. Oh,
Remind us.
I'll give you the example of the integers. So clear. There we go. The integers are the set of all numbers. I'm just going to give a couple of them. The whole numbers, including the negative and 0. All the whole numbers, including the negative counterparts and 0. Those are integers. So if you're a polygon, the deal is your exponent is a positive integer. I was always taught that 0 had no sign, but for some reason, we consider it to be positive. That has changed since I was a kid. That or the teachers 30 years ago had it wrong. I couldn't tell you. That has changed since I was a kid. They probably had it wrong, to be honest with you. So when I talk about whether something's a polynomial or not, I just wanted to care if the exponents are positive integers. That means no fractions, nothing funky looking, no negatives. All right, so we're going to go through these 5 here, and we're going to decide if they're a polynomial, then we'll worry about the rest of the instruction set. So we're going to do the first thing, identify whether the function is a polynomial. Is example A a polynomial? Focus on the exponents. That's what matters. What are the exponents in example A? Exponents are 4 and 2. Are those integers? Is it a polynomial? It's poly. I'm just going to write P-O-L-Y. In example B, what are your exponents? 2 and what? Don't forget your understoods. That x has an understood 1. Your exponents are 2 and 1. Polynomial? Yes. How about C? 3 and -2 and also 1. Understoods. The exponents are 3, -2, and the understood 1. Is it a polynomial? Why not, Nathan? There you go. Negative exponent is not a polynomial. What's the exponent on B? What can you multiply anything in existence by and not change it? 1. So here's something else you can do. You can say that 3 is 3x to the 0. Am I changing it? I'm not changing the appearance. I'm not changing the value. Huge difference there. What's its exponent? 0. 0 is actually classified as a positive integer. Is it a polynomial? Yeah, it's a polynomial. Even though there's one thing, I can always say like plus 0 and bam, 2 things. It's polynomial. I know that seems funny. That bothers me in this way. Still bothered by that. How about E? Poly or not? Why is it not a poly? Fraction, not poly. We've got that exponent of 3/2. 3/2 is a rational number. I don't know if you remember that word or not. All right, so we did the first part of the instruction set. It was identify whether the function is a polynomial. Second part is if so. So I've got to do this something to 3 of these things. If so, write the standard form, state its degree, type, and leading coefficient. So we decided example A was polynomial. Is it an STD form? Standard form is where you work with your exponents in decreasing order. Start with the highest power and work your way down. Yeah, it is. The standard form of quadratic was what? AX squared plus BX plus C. It went high to low, didn't it? That's standard form. It doesn't matter what the degree is. That's standard form. Standard form is always high to low. So this thing's already given to you in standard form. What's next? State its degree. If you look at this thing, the first thing you see is x to the 4th. What degree is that? Just the 4th degree. It also says, state its degree, its type. It's a 4th degree polynomial. Does anybody know what you call a 4th degree polynomial? Probably not. I've done this a long time. I don't think anybody's ever known. Anna might have, but that was a long time ago. Type is quadratic. Sorry, not a quadratic. The type is a quartic. A little bit Anna and Laurel. They're pretty sharp.
I was thinking it has to be quads, which quad is 4.
You would think that, but we don't call quad is something else. That's always bothered me too, but I didn't write this stuff. All right, leading coefficient. What is it? 1, because there's an understood 1 sitting right there. Leading coefficient is the number 1. We also decided that example B, even though it looks kind of funky, is a polynomial. Is it an STD form? No, what would it look like in standard form?
I squared. plus 7x minus 4.
5x squared plus 7x minus 4. I'm okay with that. What's its degree? Second. What's its type? How do we classify it? Oh, it's time for like a super lame math dad joke. You guys don't know what its type is. What do baby parabolas drink? What do baby parabolas drink? It's a lame joke. Tell you. Math dad joke. What do baby parabolas drink? Quadratic from.
Hello.
Why did I mention that on this particular problem? There's an x that's squared, isn't it? X squareds in the graph, and what do they look like? Parabolas, and what do parabolas drink? Quadratic formula, so what's the type? Quadratic. If you understood math, you'd understand why that's just a little bit funny. But you don't, so it's going to make nonsense. If you see x squared, what's the graph going to look like, kids? A parabola. And we solve quadratics using what formula? Quadratic formula. Okay? What's the leading coefficient? I. Leading coefficient is pi. We also decided that d was a quadratic. I think we wrote it as 3x and 0. I think it has no choice. It's already in standard form, isn't it? Nothing you can do that thing. It's in standard form. What's its degree?
I guess it's 0.
It is a 0 degree. The degree is 0. What is f of x or g of x or d of x fancy for? This is really y equals 3. By knowing what that looks like, I can classify it. If you were to graph y equals 3, what would you draw? Draw a horizontal line. Simply, the main thing is you draw a line. How do you classify something that is a line? What's its type? Linear. Thank you. It took 3 periods to get that. Yes. The type is linear. I'm not kidding. It took 3 periods to get that answer for you. Linear. Leading coefficient?
3.
3. The only thing, what else could it be? Could it be anything else? It's got to be 3. All right, so that's identifying polynomials.
How are you supposed to know the type?
You know, some classes do because they've had more ambitious teachers in front of them. Some
Are you just
don't.
gonna ask us what the type is for this random stuff?
Honestly, it's kind of expected that you know it by now. But you guys have also had 2 years of your own education. And you're doing most of your learning on a platform called IXL. There's a lot of stuff you're not getting.
Yeah, I've never heard of that.
Huh?
I said, yeah, I've never heard of that, the type.
Yeah, there's a lot of stuff you're not getting.
You're supposed to know that.
By now, yeah.
Like, I've never heard of quartic. Like,
Well, that's not too surprising. I mean, of course, I did some of that when I taught geometry, so I thought those kids understood that. I didn't know what it was. Oops.
We didn't know what that was. Like, I could probably tell you linear, and that's it.
There's a group of kids not too long ago that I was the only math teacher they did. Freshman, sophomore, junior, senior. That was a fun group. All right, for this function, f of x is 2x to the 4th minus 5x cubed minus 4x plus 8. Find, f notation. Most of you in here are pretty good. But for some of you, why the f don't you get f notation? Why don't we get it? Nathan, what's it mean to find f of 3?
Plug it in.
So you understand f notation. You kind of mess up on your computation stuff. What it means, let x be 3. Now, I'm going to do all this in the calculator, and I would like if you guys would play along the same way I do. The same way I do. Not your way, my way. I understand everybody wants it to be their way. This ain't Burger King. Huh? I want to use the storage feature. Because I'm going to use this function. If you look at the problem, I'm going to use this function 3 different times. All right? So the first thing up there is f of 3. Hit the 3 key, hit STO, which is right next to the 1 and the 4. You'll see an arrow pop up on the screen. And you store it where? X. Some kids know this, some kids don't. And then you type the function in. 2x. If you want to raise an exponent, if you look right underneath the clear key, you see the clear key, you will see the rooftop. That's what I call it. And that'll raise you in exponential space. 4, you'll have to arrow out of it. Don't keep typing. You've got to arrow out of the exponential space. Minus 5x. Again, I got to hit the rooftop key. Cubed. Plus, sorry, not plus, minus 4x. Be very, very careful about what you're typing. I can think of at least 4 occasions where kids have taken that big test at the end of the year and they weren't even looking at what they were typing. They started typing up in an exponential space. And then they hit graph. How well do you think they did? You understand what I'm talking about? They just kept typing up in the exponential space. They never even looked at the calculator. Kids do it all the time. They don't look at what they're typing. Then press the enter key. There's F3. Should get 23. Now, I realize that if you're only doing this once, this may not make sense to use. But we're going to do it 3 times. Next time I do it, I'm going to type find f of -1. So I'm going to repeat the process. -1, you got to use the negative key, not the minus key. Store to x. And there's lots of ways of getting previous work, but with these space plates right here, you just press the up arrow until you have your previous work. Grace, you have, Parker, you help?
Yeah, I got -1, but like, just,
No, store.
just
Press enter. And you can use that up key to pull back, to pull that function that you already typed once in. Enter. Enter. 19. It saves you from making typos again, because you're going to make typos, aren't you? Everybody is. Just check it once and know it's there. You get a 19 back. If I ever give you something that big, you'll be able to use a calculator. And I'm not going to, small numbers on the basics quiz, no, but something big, you get to use a TI-4. C is what is the average rate of change over the interval of 3 to 5 of f of x. All right, so formula time, right? What's the formula for average rate of change? F of b minus f of a over b minus a. Does anybody realize in here that this is actually slope? Harley says she does. You can think of 3, 5 as x1, x2. And if you plug x's in, what do you get back? Y. So this is y minus y over x minus x. That's all it is. It's just written out differently. Some teachers teach average rate of changes in slope formula, and I've done that for years, but it doesn't work. So this year, you're going to try it. Teach you the actual formula. And it has worked better. It's worked much better. There's A, there's B. Now, I think we already found f of A, didn't we?
Yes.
We sure did. All right, we already know part of this. We know that f of A is 23. We just need to find f of B. And we find f of B by letting x be what? 5. 5, so x. Up, 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 up. Enter, enter. 613. Substitution in. Now where I see f of b in my formula, what's it get replaced with? 613. Take away f of a, which is 23, over b minus a, 5 minus 3. Now here's what I want you to do. I don't want you to do any math in your head. I want you to punch that in the calculator. No math in your head. None. Punch that in the calculator. Do no math in your head. None. I don't care if you know what 613 minus 23 is. I don't care if you know what 5 minus 3 is. Do no math in your head. and punch buttons. You understand me? What you got there, say?
6 and 5.
He's on,
Let's see how you typed it in.
okay, just like that.
Oh, good. No. What'd you get? 605. That's a common one. Okay, what'd you get?
6 and 5.
605. Milo, what'd you get? Punch it in. How you think it needs to be punched with no math in your head. Harley, what'd you get?
613 minus 23.
No, the whole thing. I want you to type the whole thing in the calculator with no math on your head.
295.
Did you do any of that math in your head? Or did you do it in multiple parts? I want you to type the entire thing in at once. That's what I want you to do. There's a reason for this. I'm glad you got it right. Most kids don't. Tell me what you get. 295. Did you use parentheses? Use parentheses. Good. You're doing it piece by piece. I want you to type the whole thing in. I already been struggling with that. A lot of kids will default to typing things in their entirety. And over half the student body would type this like this. And they're going to be wrong every blasted time. What's the ninth commandment of math? Read it. Thou shalt always wrap 2 or more things. You're going to let a calculator do all of your train of thought, which a lot of kids like to do. Anytime you encounter 2 things, you have to wrap. That applies to in Algebra 2 and outside of Algebra 2. Specifically, 295 is your correct answer, kids. Pay attention to that lesson. Just because you can push buttons on a calculator doesn't mean you get the right answer. You get that? It's how you use the calculator. You're going to use the TI-84, you wrap. If you're going to do all the train of thought with the calculator, you definitely wrap. All right. That was actually the most important lesson on this. Here's mother functions. First up is y equals x. The reason we call it a mother function is because all lines look something like y equals x. Y equals x is the first line you probably ever learned how to graph. It looks like this. Doesn't it? Crosses through the origin. What's its slope? 1. If you don't understand that, there's a table there you can fill out. But it's going to rise 1, run 1. It's going to go back 1, fall 1. All lines look like that, don't they? They might have moved around. They might have moved up or down. They might be steeper. They might have negative slope, but they all look like that. That's what I call a mother function. Y equals x squared is something you've been graphing for a solid month. What's x squared look like? A parabola that drinks what? Quadratic formula. Okay? 3 key points on it are these right here. If you take a -1 and throw it at y equals x squared, what's it return? +1. If you throw a 0 at it, 0. Throw a 1 at it, 1. So 0, 0, back 1, up 1, right 1, up 1. There's your little baby parabola. All right, next up is y equals x cubed. Any of you guys know what y equals x cubed looks like?
Yeah.
Very close. There's usually not, the mother function doesn't have any squiggle yet. Y equals x cubed starts low, ends high. My base of my neck would be the origin. That's the actual curvature too. Starts low, ends high. The little table here is for you so that makes some sense to you that I'm just not making stuff up. If you take a -2 and multiply it by itself 3 times, what do you get back? -8. If you do that to a -1, do it to a 0, 0. You do it to a 1, do it to a 2, 8. Anything that has a 3rd degree exponent will look just like this. It might have some stuff going on in the middle, but by and large, it's going to behave like this. You go back 2 and you go down 8, which I can't do. Back 1, down 1, 0, 0, right 1, up 1, right 2, up 8. Specifically, there's more to it. I think has an odd exponent. There's a lot to be learned from this one function. All right, next up is y equals x to the fourth. What do you think she looks like? Well, let's make a table of values. You throw a -2 at x to the fourth, what gets returned? It's -2 times -2 times -2 times -2, 16, that's right. But if you throw a -1 at it, 0, 1, and 16. And I ain't got enough space for 16. You probably don't either. It's also a parabola, although it is flatter at its base. That's really hard to show. I'm just gonna have to accept my word for that. It's a parabola that's a lot flatter at the base. As the exponent goes up, it then gets flatter at its base. Then finally it starts rising and it starts going ridiculously quick. There's x to the fourth. Looks a lot like x squared, doesn't it? Y equals x. What's the understood exponent on that x? 1. These two things have odd exponents, and both of them start their day low and they end high. The squares in the fourth, those are even exponents. They both start their day high and they end their day high. That's something called end behavior, which is probably the next thing in your notes. End behavior is how a function behaves. That's its values of y as x approaches very large positive or negative numbers. Very large positive number is the concept of infinity. A very large negative number is the concept of negative infinity. So if you want to replace those words with positive and negative infinity, that's fine. All right, starting off, we're going to do a degree. We're going to have an x to an even exponent. Make sure you write the word even up there in the exponential space. That used to be a problem for girls, but I've noticed now it's the boys that have such big, god-awful handwriting that they just can't put things where they belong. The girls are real big, now it's the boys whose handwriting's horrible. Usually girls have very large, pretty handwriting. Boys tend to have very small, horrible handwriting. Right, Parker?
That's not bad. That's not bad. It's small, but it's not
Small part is what I was going
bad.
for.
But it's not bad.
Most boys are at small. All right, so x to the even, the leading coefficient is negative. Sorry, positive. We'll start off with positive. So I'm thinking about things like maybe positive x squared, positive x to the fourth, x to the sixth, and so on. Even things that are positive. Think about the mother functions I just wrote. Okay, you had x squared and x to the fourth. Both of them started high and ended high. That's how these things behave. I don't know what goes on in the middle, but I do know what we call the end behavior. Start high, end high. Yeah, there's some notation down there that's kind of funny. So pay attention definitely on the first example. As x moves left towards negative infinity, what happens to the y value f of x? 2. It's going to go up forever. So it increases to positive infinity. Now, as x moves right towards positive infinity, what happens to the y value? It goes up to infinity. Moving on to the second example here. This one is going to be still x to the even, We're gonna change the leading coefficient to be a negative number. We're thinking like negative x squared, or maybe negative 2x to the 4th, or something like negative 10x to the 8th. We're thinking about all that, even exponents with negative numbers out front. Don't worry so much about the numbers I put there. Think about what you've seen already based off other functions and stuff you've learned in the past. If it's negative, what happens to the graph? You still like that word flip, don't you? Reflects. It reflects on the x-axis. So instead of starting high, start low. Instead of ending high, and low. Some of the student body is the first graph. Some of the student body is the second graph. Lots of kids start the day high and end the day high. They do. Most teenager ones. And lots of kids start the day low and end low. All right, so as x moves left to negative infinity, what happens to the value of y? It also goes to negative infinity. As x moves right towards positive infinity, what happens to y? Still negative infinity. 5 of 8 done. You're almost ready to me. What, 10 minutes left? Sadly. So we just did all the x to the evens. What do you expect is next? X to the odds. Both of them are going to be x to the odd. One of them is going to be positive, and one of them is going to be negative. So when you talk about x to the odds, you're talking about like x to the first, or x cubed, or x to the 21st. Doesn't matter. It is an odd exponent. That's all that matters. And I graphed two other functions for you today, x to the first and x cubed. Even x to the first started its day how? Low. And how did it end its day? High. All of them do. All of them do. They all start low, and they all end high. If you make that leading coefficient negative, so now you're thinking something like negative x to the first, or negative x to the 29th power, whatever. If you make that leading coefficient negative, what's it going to force on the graph? Please don't say flip. Reflection. Thank you. It forces a reflection. So instead of starting low, you're high as a kite. You run out of drugs, and what happens? You crash. If you like drugs, I hope that helps. Okay. There's that funky notation at the bottom, first graph on the left. As x runs left to negative infinity, what happens to the y value? Also goes to negative infinity. As x runs right towards positive infinity, what's happening to the y value?
Goes to infinity.
Goes to infinity. The odds are just going to be the reverse. As we run left towards negative infinity, y goes to infinity. As x approaches positive infinity, y approaches negative infinity. These are just concepts most of the day, kids. Nothing too hard, just concepts for the most part. Of course, the hard part is memorizing and keeping on to it. Most kids do pretty well though in that behavior. They tend to remember it quite well. All right, determine what you know about the degree and leading coefficient of the polynomial shown below. Just focus on M behavior. Example A, how's it start? Low. How's it end? I don't care about anything in the middle. I care about how it starts, how it ends. What do you know? It starts low, ends high. Look at your notes. What is it?
Next one.
It's an x to the odd. Because that's how x to the odds behave. Specifically, it is a positive x to the odd. It is a positive x to the odd. I don't know anything else about it. It could be a third. It couldn't be a first degree, could it? No, first degree would be a line. But it could be a third. It could be a fifth. It could be a seventh. It could be a ninth. One thing I know is it's not first degree. How about example B?
Negative x to the even.
Negative x to the even, that's right. because this thing starts low and ends low. The evens always start and end the same way. Always. The odds are always opposite. Why negative?
Because it starts going.
Yeah, it's upside down. Reflection. All right, any issues with that? See if we can get something graphed. Use what you know about end behavior and your ability to make a table to roughly sketch g of x equals negative x cubed plus x squared plus 3x minus 3. You're one of my smarter groups here, so I want to teach you something. I couldn't do it in the fourth period. Here's an introduction to factoring by grouping. What do the first two terms have in common?
It's
X squared. Pull it out. I actually can do something a little contradictory. I'm going to pull out the negative x squared. If I pull a negative x squared from negative x cubed, what remains? X. If I pull a negative x squared from a positive x squared, what remains? Negative 1. All right, this is a factoring by grouping technique, which you'll learn about pretty soon. Same thing to the back. What do they have in common? Pull it. Pulling a positive 3. If you pull a positive 3 from 3x, what's left? Pull a positive 3 from negative 3.
negative 1.
So what you've done is you've gone from 4 distinct pieces to 2. There's only that plus sign in between. What do they both have in common? Both possess x minus 1. And what's left is 3 minus x squared. I just changed the order. Because it was negative x squared, right? Okay.
You not add the x minus 1 together?
No. You pull it. If you pull x minus 1 from the first piece, what's left? Negative x squared. If you pull x minus 1 from the second piece, what's left? Positive 3. Anyways, the reason I did this is because you can now tell me at least one x-intercept. What's one of the x-intercepts? 1. It's right there. There's an x-intercept at x equals 1. That's something in the table. 1, 0. There's another one at plus or minus root 3, but we're not ready for that yet. Yeah, that x squared, that 3 minus x squared, right? There's another one at plus or minus root 3. Maybe you get that, maybe you don't. Anyways, let's talk about M behavior. This guy right here, is he the biggest piece in that thing? Is he the biggest part of that polynomial? Yeah. He controls everything. We call that a power function. Power function is negative x cubed. Whatever happens there is going to control almost the entire graph. I mean, think about if you throw a 10, this thing. 10 cubed is 1,000. Who really cares what 10 squared is in the next piece? It's only 100, right? As you throw bigger and bigger numbers at this thing, that thing controls everything. Everything else is just a rounding error. How does negative x cubed behave? Starts high, ends low. Whatever I graph, I know it's going to look like this. The rest of this is going old school and plugging in numbers. At this moment in time, for y'all, it's old school and plugging in numbers. And I really don't feel like boring you with plugging in numbers, so I'm going to show you how to cheat. Are you okay with that? Go to y equals and type in the function, but don't hit the graph key. The idea is still somewhat that kids understand how to graph by hand, so I still kind of want you doing some of this with your pencil.
You was typing the original function?
Yeah, type in the original function, because we might have screwed up somewhere. I'm exhausted. Don't trust me today. Again, don't look at the graph, all right? The idea is freehand. Most kids can plug in numbers. I just don't want to bore you with the time of doing that. If I want to know what the graph looked like when x is 4, what would I plug in? 4. If I want to know what the x graph looked like at 2, I'd plug in a 2. Most kids can do that. Everybody got that typed in the y equals? Hit that table key. Second table. Guess what's there? Table. Some of this stuff, I can't even plot -3 on my graph, can I? Why not? It's 24. Does it make any sense to write that down? Does my grid go up to 24 units? No. I just want these. There's -2, 3, -1, 4. Sorry, that was -2, -3, wasn't it? What was it, +3? -1, -4. 0 would be nice. 0 ought to be -3. 1, 0, which we already have, 2, -1. And then there's 3, and it is -12. I think this grid goes that far. So use the table feature. If you got a TI-84 at home. Back 2 rise 3. Back 1 fall 4. 1, 0, 0, -3. 2, -1. 3, -12. No, right at the bottom of the graph. Now look at some of the points I plotted. The -3 point was way off the grid, wasn't it? You look at your table, it was -3, what, 24? That's already off the grid, isn't it? Is that expected? Wasn't this thing supposed to start high? +3 was 12, all the way at the bottom. Was that expected? Because it was supposed to end how? Low. Now, as far as drawing, you've got to kind of hit your points from left to right. When I hit this guy right here, what has to happen? I have to curve up, don't I? When I pass through that guy, what's going to happen here? I have to curve down. A lot of kids struggle with freehand graphing, which just blows my mind. Connect the dots. That's all you do. You connect the dots. Some kids do funky stuff. I'm going to show it to you. I shouldn't show it to you. But the amount of weird stuff I've seen over the years, this is the right graph. I've seen kids like come in from over here. Like they'll draw stuff like that and they're like, what's wrong? I connected the dots. You connected the dots wrong. It has to go from left to right. All right? Don't be that kid in green. Be the kid in pink. That's it for today. Remember, you have a basics quiz Thursday.